Hello everyone, thanks for joining. My name is Barak Nissim, Director of Technical Solutions at Ionir. This video will demonstrate the power of Ionir's clone-to-time capabilities and CSI integration. We will create a clone of a sample production MongoDB volume to a different namespace to enable developers to access and test the actual production data, and also demonstrate recovering a database from a failure using Ionir time clones, all by using basic CSI volume cloning YAML files. Let's start. This is the Ionir Cloud dashboard, where we can see our Kubernetes clusters with Ionir platform deployed, and some other basic information about capacity and efficiency. Let's click on the cluster and explore the MongoDB workload, where we can see that we have a single persistent volume of 50 gigabytes with a 6-hour history policy. The history policy defines the time scope for which clone to time will be available for a volume. Let's now switch to the command line. We are in the MongoDB pod. ShowDBs lists the set of databases with their sizes. We will work with TestDB in this demo. Let's run a basic query to make sure that things are working. Perfect. We have a database operating as expected. This is our sample production database. Let's quickly go back to the UI to see how we can clone volumes. When creating a clone, there are a few parameters like the name of the clone, history policy, which we previously discussed, the target namespace, and the time of the clone. For this video, we will be creating clones using the CSI volume cloning API. Ionir supports this feature and with extensions to support our unique capabilities. Let's get started by looking at the YAML to create the clone. We have specified the name of the new clone, the target namespace, and annotations to direct to the source PBCM namespace, and some general information on the volume. Going back to the console, let's apply this YAML. Switch to the Mongo test namespace. You can see that the clone is ready in less than a second. Now let's deploy a basic Mongo app that will use this clone as a persistent volume. The pod is up and running. Let's go into the pod and check our database to make sure that everything is there. Perfect, that was quick. Now let's see how we can use the clone to time capability to recover the production database after an error causes data loss. Let's go back to our production database in the Mongo namespace. Select TestDB, and we drop it. Now, when we run our query, we see that there's no results returned, and the database is gone from the DB list. We have another YAML for cloning that adds time as a parameter to the clone operation. The YAML expects time to be specified in this format. Let's add it to our YAML and go back a couple of minutes before the database was deleted. Of course, we can select any time at a 1-second granularity within the range allowed by the history policy. Apply the time clone YAML to our Mongo recovery namespace. And apply the Mongo pod the same as before, just the right namespace. Let's connect to the Mongo pod that we just created with the time clone PVC. We can see that the TestDB is back online, and all of our data is back in seconds. Going back to the UI, we can see our 3 volumes, the original volume, the clone, and the time clone, all in different namespaces and attached to different workloads. and creating the clones did not increase the space consumed. All volumes, clones, and time clones are deduplicated and thinly provisioned. That's all for now. We saw how easy it is to clone and recover persistent data on Kubernetes with Ionir. Thank you very much and see you on the next demo. Meanwhile, please follow, like, or visit us on www.ionir.com. Goodbye.